right. Let me just quickly introduce you. We got two more joined. Right. We have the honor today to talk a little bit about value and data visualization with Nimrita, who was so kind to actually participate in this talk. And she will show you how you can use Python code to actually demonstrate the value of data visualization for data science and ML projects. And without further ado, Nimrita, the stage is yours.
Thank you, Jousef. And hi, everyone. Thank you for joining this session. We are going to talk about the value of data visualization. A brief outline, I'll be talking about the importance and impact, and we'll see some principles of effective visualization, some challenges which are posed by heavy influence that visualization has on us humans, and then we'll walk through the Python code to demonstrate how it can really help data analytics projects in general and ML related projects. Here are the references I have used to put together this Jupyter notebook. Really very good references. So data visualization is nothing but representation of data in the form of visuals, in the form of graphs or images or infographics, charts. The whole purpose is to convey your message as clearly as possible, as simply as possible, so that your audience can can receive your message and take some useful actions out of it. So here's a classic example of why data visualization is important in addition to the statistical analysis of data. This is Anscombe's quartet, which are a set of 4 data sets which have different values but same statistical properties, like their means are same, their variance is same, the sample variance is same, the correlation between X and Y is almost the same, yet if we plot these graphs, they happen to have a very different kind of distribution. All 4 data sets look way more different from each other. So this was a demonstrative effect from Anscombe to show that although your statistical properties reveal the same thing about the data, visualization can reveal something counterintuitive about the data sets. So after this effort, there have been many other researchers who tried to demonstrate that data which has similar statistical properties can reveal differences when it's plotted visually. So this property has been of great help in ML projects, and it has been able to help us perform way better data pre-processing and fine-tune the models and improve their performance way long. So data visualization is basically about communicating your message well to people, enabling them to receive your message well, engaging with your audience in a better way. We are looking at a data set here. This is basically the output of a pandas data frame in Python. And this is about the temperature of certain countries in the world from 1743 to 2018. And by looking at this data set, there's not much of insight, there's not much of information we can gain. The same data I have presented in the form of a very simple bar chart, right? Just by a single look at this bar chart, you can see that the countries like Qatar, Sri Lanka, and UAE have been the hottest countries, right? As compared to China, South Korea, Japan, and so on. And there are countries like Indonesia and Malaysia, which are moderately placed in terms of temperature. So is with Iran, Israel, etc. So that's the quickness that is added to engaging with the information, to understanding the information if we present it visually. Of course, there are reasons for it. The reason being that human mind has evolved to receive the visual information way more efficiently than the textual information or any other kind of information. So it's also said that around 93% of our communication is verbal, and we can process an image in around 30 milliseconds as compared to the time we take to process a data set, an Excel spreadsheet or a data set in the form of a pandas data frame. My bias is towards Python and pandas, so please excuse me for that. There are other tools which can do the job really well as well. So many researchers have demonstrated, both academic researchers and the corporate researchers have demonstrated the effectiveness of using visual aids, graphics, infographics for businesses, for government, even for academic purposes. So as per the references 6 and 7, we have seen, they have reported that for businesses, if you're using visual aids, information graphics, you can increase the customer engagement by 30%. And the business meetings, the duration of business meetings can be reduced by around 24%. It's a huge saving in corporate time. And you can increase the ROI by around $13 on every dollar you spend with the help of visualization and BI tools. For government also, the compliance of directions which are presented visually has increased by 323% as compared to the directions that government gives in text form. Similarly, it has been observed that the research and academic findings which are presented visually increase the credibility of those findings by around 29%. So a good visualization and effective visualization not only will help you to present your message, it will also help you to engage at a deeper level with your audience. You can tell stories around your visualizations. The stories will not only enable you to share your data and your information, they'll also enable you to share your experience around that data. And we as humans, connect better with stories. We relate better with experiences, and we are able to connect the dots for ourselves and put to use different experiences of the speaker instead of just looking at the data set. It's way more comfortable for us, engaging for us to hear the story and see the data in the form of visuals, connect the dots in those visuals, and so on. So here are some good, effective principles which help you to create good visualizations that serve their purpose well. These principles more or less come from David McCandless, who is a well-known British data journalist. He has very good couple of books on data visualization. He has his own website, which is very good resource for anybody who's interested in going deeper into data journalism and understanding the real impact of data visualization. So David says there are 4 important elements. There are 4 important components for any visualization to be effective and successful. The first component obviously is the data or the information that you would like to share. The second important component is a story, a narrative which you build around the data. And this narrative is what gets you closer to the hearts of your audience and has a lasting impact on them. Third important component of any successful visualization is a purpose or a goal. Obviously, you have an end in mind. That's why you are making a presentation. That's why you are sharing your data. And the final thing is a visual form, a graphic, a chart, an image, whatever you're using as a mode of communicating your data. So this is the same concept presented in the form of an image. Again, the image is from David McCandless. It shows that you have 4 important components to your successful visualization. There is certain implicit component, there is certain thing which is implicitly carried out if you are including these 4 elements in your visualization. So we know that it's very, very difficult for a human being to look at a data spreadsheet and get anything meaningful out of it without doing extensive analysis using a software tool or something like that. But having a visualization, having a graphic sorts out this problem for you. Here's an example again from David. This example is talking about how many times media has inflamed the fears, how many news items the media has carried out about various events throughout the history, right from 20,000 to 2018, about events like asteroids hitting the earth or a Zika virus outbreak or some millennium bug, SARS virus outbreak and all that. So this graphic can show you in one look that this event here had the highest number of news items covering it. And incidentally, it is also seen in the next graphic on David's website that this virus outbreak of Ebola did not result in as much deaths as were due to this swine flu, right? So these media stories led to so much fear and terror in the audience just by the number of times they were aired and shared with the audience. There are certain principles that we need to follow in order to make your visualizations effective. So the first and very important principle is that you should choose the correct type of chart. We have already, we have so many types of charts. There's a line chart, there's a bar chart, there's an image, there's a graph, there's a map. So among all of these, you first need to choose which is the simplest and the most correct one for your purpose, right? And prefer simpler charts. If you can convey your message with a simple scatter plot, there's no need going in for a map or a more complicated one. The second principle is that we need to optimize the data ink ratio, which means we focus on the essential parts of your graph, which convey essential message, and just let go or reduce the amount of ink we spend on non-essential parts like legends or the decoration around the legends and so on. We use the orientations effectively so that the chart is more readable and it is better able to be understood by the audience. Of course, we use the colors cautiously. Right now, there is a lot of discussion around using inclusive color schemes, right? There are certain countries, certain parts of the world where certain colors are thought to be, not so good, not so favorable. So we need to take care of that mindset, the cultural mindset also while designing the color schemes for our charts. And of course, we minimize the clutter in our charts, keep the elements that you put in your charts, in your graphics to a minimum, adjust the amount of lines or segments which are required to convey your message and nothing else. And definitely we avoid any bias, any misinformation, any misleading claims or deceptive visuals at all. Right. So we see that the visuals carry huge influence on human brain. We get very influenced by visual information. So this also brings in its wake the danger. The danger is that we can easily be misled. We can be influenced by wrong information. There are certain characteristics that we can look for in a graph in order to identify or in order to suspect that the graph may contain misleading information. Here are 8 or 9 factors that we can look for. The first one is that your y-axis does not start at 0. This starting your y-axis at the value you desire it to be can help you magnify or reduce the differences between the values when you are doing a comparative charting, let's say about the profits of your company and your rival company. Next thing which can mislead, which is deceptive, which may be deceptive, is having 2 different y-axes for the same parameter. You can focus only on desired part of data for presenting your graphic. That means you don't represent the full data and just focus on data which is favorable for your particular purpose. You can group your data in a misleading way while presenting it. We can deceive using colors also. So using a non-monochromatic color scale for a single quantitative variable can also be deceptive. Again, there's a problem with pie charts, which is well known, right? Sometimes pie charts are not very decipherable. They're not very clear when looked at, especially in 3D pie charts. Another problem that pie charts easily give away is that the sum of percentages does not add up to 100. You can also deceive or disguise insightful trends in data by using a cumulative chart. Then there can be inconsistency in the title of your visualization and the actual content that visualization is displaying. This inconsistency is often a strong indicator of bias or an attempt to mislead the audience. Then if you're plotting smooth trend lines on top of your scatter plot, it can also be an indication that you're trying to mislead the eye of the audience to something which is not there actually in the data set. So you can use visualization to tell your story, but it's very easy to tell a fake story using your visualization. So the aim for us, especially in the scientific world, is to tell a fact, to convey a factual story. It will lead your audience to act, and hopefully the action that you want your audience to take is a desirable action based on facts. Next, we'll quickly look at some Python code, which helps us to see how visualization helps us to understand the insight or understand the information way quickly than just looking at data sets. So the data set that I'm using for this example is coming from Berkeley Earth. It contains the average global temperature across all the continents of the world, starting from 1743 and going way into 2013. So we will not be using all the years of information. I have focused from 1950 till 2013 by dropping the rows which belong to previous years. This is programming in Python. So I've imported all the libraries that are required for this particular code. So that's NumPy, Pandas, Matplotlib, and Cburn. The data set which I have downloaded is present on my hard drive. I have read it into a data frame using read_csv. You can do basic data exploration using functions in pandas like head, shape, describe, dtypes, and info, etc. So I'm not sure whether I'm not sure whether the audience is comfortable with Python and in how much depth should I go with the code, but I'm assuming a reasonable amount of familiarity with the Python, so I'm not getting into very in much detail about the code. So this data set has been read into our data frame, and here we are looking at first few rows of the data set. There is the date column, there's the average temperature, there's the uncertainty in measurement of that temperature column, and then there's the name of the region of which this temperature is recorded, right? So we see with shape that there are around 5,77,000 rows in this data set, and there are 4 columns. We can look at the data types of all 4 columns using the dtypes attribute of a data frame in pandas. We saw that there are certain nans, which means the values are missing. There are no recorded values for these 2 columns for these rows. We can drop all such rows using drop NA function. Again, if we look at the shape of the data set, we see that now there are only 5,44,000 rows. So around 30,000 rows, 33,000 rows have been deleted, which contained missing values. So this is our new data frame where the missing values no longer exist. Then we'd also delete the country like A land, which was a region long before, and it no longer exists in the current globe of the world. So we just drop the rows where country value is A land. Again, we see that now another 2,000 rows have been deleted. Next, we are going to add one more column to our data frame. When we are doing a data analytics project, this kind of data pre-processing or exploratory analysis of data is an important part, is a necessary part of every data analytics project. So we will be adding a new column called year to the data frame that can be done by extracting from the original DT column just the year part of it. Then we drop the original DT column, and the resulting data frame now contains 4 columns: the average temperature, measurement uncertainty, country, and the year in which this temperature was recorded. Next, I would also like to drop all the years which precede 1950. So we'll just retain the rows where the year value is 1950 and onwards. That can be done by using the log function and dropping all the years which are less than 1950. And next I'm focusing on the Asian region. Well, I'm in Asia, so it's just by chance. So we are focusing on the countries which fall in the Asian continent, and I'm extracting only those rows which talk about these countries. I have finally around 9,000 rows and 4 columns in my data frame. If I print the first 5 rows of this data frame, this is the information I get, right? I start at China, and then I have countries like India, Indonesia, Iran, Israel, Japan, Malaysia, and so on. Next thing I do is that I want to group the rows which talk about same country. So now the group by function allows me to group all the rows together where the value of country is same. So I now have one group which corresponds to each country in my list. I'm looking at the data about the country China. So you can see average temperature in 1950 was -6.11 and so on. And next we will group this data on the basis of year also, so that we can see one value for that year. Next, we are grouping our data frame and finding the average temperature country-wise. Here is the resultant data frame. This data frame contains for each country in Asia, the average temperature and the measurement uncertainty of this temperature. Next thing we do is the plotting. So looking at the data like this is not very, it's not very interesting also, and it is not very insightful also. So we are using matplotlib to plot a basic bar plot which shows us these temperatures so that we can compare them just by a visual look. We have the average temperatures. We divided these average temperatures into 3 quantiles: quantile 1, quantile 2, and quantile 3. I want to plot these bars in different colors depending on the average temperature values. So I have put this criteria that if the temperature is less than quantile 1, then the color of the bar should be blue. If the temperature is between Q1 and Q2 of average temperatures, then the color of the bar should be green. If your temperature is between Q2 and Q3, then the color should be orange. Otherwise, if the temperature is greater than third quantile, then color of your bar should be red. We set the parameters like size of this canvas, size of this figure, and then we go ahead and plot the bar plot. Here you can see with the visual inspection itself that countries like China, South Korea, and Japan are at the lower end of average temperatures over all these years from 1943 from 1950 to 2013. The countries like Iran, Israel, and India have been in the lower, less than Q2. The countries like Indonesia, Malaysia, and Thailand have been between Q2 and Q3, and Qatar, Sri Lanka, and UAE have been at the higher end of the average temperatures for these 63 years. Next, we would like to have a look at the data arranged by groups or arranged by years or grouped by years. So we have years 1950 to 2013 in our data set. We are again creating the data frame, which now will show you the temperatures year-wise from 1950 to 2013. Same data, now we'll have a look at it in a visual form. We plotted this data like in the previous cell using bar graphs. For the temperatures which are less, we are using a different color. For the temperatures that as they go on, becoming hotter and hotter, we shift the color scheme to red, from blue to green to orange to red. So looking at these bar graphs, you can see that in 1950, most of the countries were blue. That means the temperatures were less. Between 1951 and 1955, the temperatures were in the green region. Something happened again in 56 and 57, and the temperatures again reduced. There was a slight spike in temperatures in around 1958. Then we see that around 1990, all of a sudden, the temperatures increased. In 1990s, I guess this is the onset of industrialization in Asian region in a big way. So that was the reason for this spike in the temperatures. We see that from 1998 onwards, there has been a steady increase in the temperatures, right? So we didn't have to look at the data frame. We didn't have to look at the Excel spreadsheet to understand this, A visual look can tell us that from 1998 onwards, the temperatures of all these Asian countries have been rising steadily. There's a next data set, which is Boston housing data set. This data set is a classic data set that the students and also analytics people use for either during the learning phases or either during their initial work experience as well. So this Boston housing data set is used for predicting the prices of houses located in urban Boston area. It has around 14 columns, out of which there are columns which speak about the crime rate in that town, the portion of residential land which is zoned on in that particular area, the amount of industrialization that is there, its proximity to the Charles River, NO2 concentration in the atmosphere in that area, average number of rooms in the house, the age of the building, and so on. So there are around 14 attributes, and MEDV is the median value of the house or price of the house in $1,000. This problem is often used for predicting using regression to predict the prices of the house. So this data set I have downloaded from UCI Irvine, which has two files basically, housing.data and housing.names. Housing.data contains the data values and housing.names contains the column headings and their descriptions. So I've combined the two files into an Excel file. It contains the headings of the columns as well as the data value. So as before, we import the files that we require, import the libraries that we require. In this particular case, I'll use NumPy, Pandas, Seaborn, and Matplotlib. I'll use read_csv of pandas to read the boston.csv file. We have printed the first 5 rows of the data, and you can see that this data is totally numerical. All the columns data is numerical. You can use info function, describe function for a bit of exploratory analysis. So with info function, you can see how many values are there in each of the columns of your data frame. What is the data type of that column, whether that column is non-null or null. Similarly, you have describe function, which helps you to see the statistical properties of every column of your data frame. These statistical properties include the number of values, number of observations in the column, mean value in the column, standard deviation, minimum value, the three quantiles, and the maximum value. So having a look at the data without doing any pre-processing is just to give us an indication of how our pre-processing, how our visualization will help us to improve these parameters later in the session. So I'm also checking for a presence of null values or missing values using a data frames is a function. So I can see there are no missing values in any of the columns. I can see the list of column headings using df.columns. Then I want to print this data. I want to plot this data. This was the data plotted without any decoration, right? Here is the same data, but which has been plotted using Seaborn library, and I've used the gradient. This color gradient enables you to identify the big values, identify the large values in every column just by looking at it, just by visual inspection. So relative gradient of green is able to convey to you that here in this column, these values are maximum. In this column, these values are maximum. The darker the shade, bigger is the value. Then we are just looking at the price and we want to see what is the distribution of the price of the house like. So we have used a histogram to plot the prices of the houses in $1,000, and along the y-axis we can see how many such houses are there, right? So by looking at this diagram, by looking at this chart, you can see that majority of houses, for the largest number of houses, the price has been in the range of, right, $17,000 to around $23,000. The next category of the next price range or price bracket is between $23,000 and maybe $28,000. The two second tallest towers in this bar chart. We see that the prices which the lowest number of houses have price around $50,000, right? And there's a surge here at $50,000, maybe those huge villas or big bungalows, which went with the price tag of around $50,000. So our average or the most number of houses sell at around $20,000 to $28,000. And next, we will have a look at the distribution of all other columns in the data set, right? So we just can use data frames built-in histogram function, and this easily plots the distribution of every column in your data frame. The data frame itself, in turn, will call the matplotlib's functionality without you having to actually worry about the matplotlib syntax and code. So we can see here for all 14 columns of our data frame, what is the distribution like? You can see that the crime rate has a very skewed distribution. Then zone has almost same kind of distribution, except there's a spike here. Industrialization is almost also uniformly distributed with a huge spike here in the middle. Same for all the columns that we see. We see that the number of rooms has a normal distribution. Age is skewed a little bit, and DIS is also skewed a little bit. So this allows you to look at the distribution of data set. It may help you to decide what models you can choose to apply on this, which kind of pre-processing, which will you require to do on if you're using a particular column as a predictor for your model. Next, we are using correlation to identify which of these columns are more highly correlated with your price column, which you are using as a target variable. So the simple method is to use the core function of your data frame. It shows you the correlation values of all other columns with the median value price or price of the data frame. This simple correlation can be made a little more engaging, a little more easy to understand by applying a bit of style on the output of this df function. This can be done using the styler module of your data frame. With the styler module, I can apply a correlation condition. I can specify certain number. Instead of numbers, I can specify certain text which can be displayed depending on the brackets into which your correlation lies. For example, for correlation of -5 to +5, use the correlation. I've used the text low. Then between 5 and 6, or -6 and -5, I've used the correlation value of medium. For other cases, the correlation is mentioned as high. So when I apply this function to the styler, here's the output that I get, right? So instead of looking at the numbers, I can now see which columns have a low correlation, which columns have a high correlation, which columns have a medium correlation with the median value or price of the house. So if I see the RM column, the number of rooms in the house has highest correlation of around 0.69 with the price of the house. So that's also indicated here to us through this color gradient, where RM has the darkest shade of blue, meaning that this column has the highest correlation with median value. Next, we are plotting the heat map, which shows us the correlation between every pair of columns in the data frame. So this heat map again is using a CMAP or a gradient of reds in order to indicate the higher values of correlation and the lower values of correlation. Lighter is the shade, correlation is higher on the negative side, and then darker is the shade, correlation is higher on the positive side. So we can see that the correlation of crime rates is around 0.63, 0.5 with the median value and the other columns. So this is how you can look at the correlation of every predictor in your data set with the target variable. Looking at the correlation is one simple way or a basic way of deciding the importance of a feature for your machine learning model. Highly correlated features can be combined together, or they can be dropped, or some of them can be dropped, and it is a way of doing feature engineering for UI, a basic way of doing feature engineering. Then we are using Seaborn library to plot the distribution of pairwise columns in our data set. So for example, here we are looking at the relative distribution of crime rate and the price, median value or price of the houses. We are looking at here the zone, industrialization zone, and again, the median value of the houses. Well, look at the differences in these graphs, right? You can see that there's a clear piece of information that is conveyed by this distribution, right? So you can look at this and see that the data conveys completely different story as compared to this data or as compared to this data. You can see that somewhere you can identify a linear trend, somewhere you can identify a rising linear trend, somewhere you can identify that there's no trend at all, right? It's a completely random distribution. There's no correlation at all. So you can affect sometimes the cause and effect relationships. Sometimes you can identify a correlation using this distribution plot. Next, we are simply plotting a regression line on top of the distributions that we have already seen in the previous plot. So you can plot a regression plot or a facet grid or a bar chart, a scatter plot, a 3D scatter plot, different kinds of surface plots, all using Matplotlib and Seaborn. Matplotlib, in fact, also allows you to plot 3D plots like 3D surface plot or 3D line plot. So in this particular case, we're just looking at regression plot, which shows you the trend, the regression trend between the columns, pair of columns, and the median value of the house. You can see that in most of the cases, the trend is not very striking, except I guess this one, where there is a straight rising regression between the number of rooms and median value of the house. This is what was indicated by correlation coefficient also. Next, we are trying to identify outliers in our columns. Outliers are the values which are too extreme, either at the lower end of your data or at the higher end of the data. So a very commonly used method of identifying outliers is a box plot. So just using df.plot.box allows you to see the box plot for all your columns. A box plot allows you to see the minimum value, the median value, the maximum value, the quantiles, and also the outliers, the values which lie way above the upper boundary or upper line of this plot and way below the bottom line of this plot. So we are focusing on the zone right now, the zone column right now, and you can see from this graph that there are a number of points which are way above this upper boundary line, right? So there are a number of outliers on the upper side of this column. This is something we'd like to handle, right? These are the values which may affect the output of your model, the performance of your model, and it will be better for us to reduce these outliers, right? Not just in zone, but in other columns also. So we are again using data.describe or data frames describe function to look at the statistical properties of the data, and we'll have a look at them again after doing the outlier removal process. Here we defined a simple function for outlier removal. This function computes the first quantile and third quantile of your, for each column, finds the interquantile range, and then I'm trying to drop all the values which fall outside the outer quantile or third quantile times 1.5 times the interquartile range. This is the standard definition of an outlier in statistics. And same thing is regarding the outliers on the lower edge, the data points which are below the first quantile minus 1.5 times the interquartile range. So all such values are dropped from every column of your data frame. This function is applied recursively to every column of my data frame. And then I have used data.describe once again to look at the changed statistical properties of each column, right? So while we had the maximum value of 88.9 for crime rate earlier, now this is just 8.98, right? Same way it has been for other columns also, where the statistical parameters have come down because the outliers, the extreme values have been reduced, have been handled. So after this outlier removal, we are looking at the box plot of zone again. So now you can see there's just one outlier, right? Earlier we had so many outliers which fall above this line, right? Just one. Right now we have just one. So if we look at the head function, again, I'm looking at top 25 rows of my data frame. The data frame looks boring, right? Non-engaging like this. And here is something we can do to increase the accessibility for people maybe who are, who have a bit of difficulty in viewing the data, or who may want to, have a bit of creativity around this simple display of data in a data frame. So this is magnify function of data frame. This magnify function allows you to select what will happen to your data in a data frame within the cell if you bring or hover your mouse over it. So in this, I'm plotting this data frame. I'm selecting the colors. I'm selecting the gradient with which the data should display. And I'm also able to magnify the data either in headings of the data frame and in the individual cells of the data frame. So this functionality itself, it's an interesting thing to do. And at the same time, it aids you to build or increase the accessibility of your data set, for helping people who may be who may have some kind of visual impairedness or some kind of difficulty in looking at small values in the data frame. So this was a very brief compilation that I came about for sharing with all of you, demonstrating how a visualization can not only help with machine learning and data analytics projects, but it can also help you to just increase or improve the visibility, improve the accessibility of your data for casual use as well, right? Not just visualization, but also visualizing your data in the form of a spreadsheet or a data frame. And if there are any questions, we have another 5 minutes to have them. And I'd be happy to get in touch with you over LinkedIn also if there are any, any projects, any small projects that we can do on data visualization. I'll be happy to connect and work on that as well. So that's it from my side. Jousef, over to you.
Thank you, Nimrita. Very great tutorial. Any questions from the audience? I'm also posting in the chat if anyone wants to delve deeper into this, plotting with Seaborn by Nimrita on Manning. So if you want to check that out, feel free to do so.
Yes.
Anything that interests you in terms of data visualization? I think that's also very useful, not only for machine learning projects, but maybe also in terms of color aspects for engineers in terms of finite element method or computational fluid dynamics, where the color also plays a big role.
Absolutely. Absolutely. Visualization, I'm speaking in terms of data analytics and ML, that because that's what my field is. But visualization has heavily and very successfully been used in the field of physical sciences, chemical sciences, thermodynamics, in machine design. I think there's a huge impact of data visualization in those fields, right?
Yeah.
Almost comparable to what it has done for ML and deep learning.
Definitely. Really, really cool. If there are no more questions, I think, Nimrita, I'll give you back 18 minutes of your time.
Sure.
And I really much appreciate you taking the time. I know it's quite late over there, but thank you so much and hope to see you in a future session.
Thank you so much. Thank you everyone for joining.
Take care.
Thank you.